Hi guys, my name is D. Srivatsa from branch CSC Data Science and from section C. Today we are going to discuss about, let's go to the next slide. It's about Frank Sprague events, the constant speed DC electric motor. The Sprague event is about to begin now. Biography of Frank Julian Sprague. Sprague was born in Milford, Connecticut in 1857. He attended Dewey High School, excelled in mathematics. Sprague won the appointment to the U.S. Naval Academy with $400 in borrowed cash. Set out for Annapolis, Maryland in 1874. Graduating seventh in a class of 36 in 1878, Sprague was assigned to the USS Richmond flagship to the Asiatic Fleet, where he filled a notebook with detailed drawings and descriptions of devices that evidenced his urge for invention. Among these were a duplex telephone, quadruplex, and octuplex telegraph systems, a motor, and a means of transmitting pictures by wire. Later, Sprague was ordered to the USS Minnesota while his ship was in Newport, Rhode Island. In 1881, Sprague invented the inverted type of dynamo, and also in 1881, Sprague transferred to the USS Lancaster, flagship of the European Squadron, on which he installed the first crude electrical call bell system in the Navy. And then Sprague took leave to attend the Paris Electrical Exhibition and the Crystal Palace Exhibition in Sydenham in England, where he served as the only American member and as a secretary of the jury of awards for gas engines and dynamos and lamps. He left the Navy to accept an invitation to work as a technical assistant to Thomas Edison. While working for Edison, he developed an electric motor that could be adapted for use with industrial machinery. He also helped with the installation of Edison's groundbreaking three-wire electrical light systems and made refinements to the inventor's power distribution system. He also introduced to Edison's firm the idea of using mathematical formulas rather than trial and error experimentation to develop concepts, and which helped the company to reel in the R&D expenditures. And now let's go to the next slide. Sprague's new interests. After just 1 year, however, Sprague realized that his interest lied with power and transport rather than with lightning systems. He was also got attracted to power and light. And now with another slide. Sprague's ideas of motors and lights. Here we can see a diagram of circuit which represents Sprague's invention or a path-breaking invention in the electrical field. Next, go to the next slide. The idea of power and light. However, Edison's primary interest was in light, while Sprague was interested in power. He resigned his position after about a year and started the Sprague's Electrical Railway and Motor Company in 1884. During the next 2 years, Sprague produced a number of inventions of major significance. The first was a constant speed, and next was non-sparking motor with fixed brushes. the first motor to maintain constant revolutions per minute under different loads. Sprague's invention caused such a stir at its first showing at the Franklin Institute's electrical exhibition in Philadelphia that the company sold 250 motors in 2 years. Let's go to the next slide. Yeah. Sprague designed a method to regenerate or return power to the main supply systems of electric motor driven equipment such as elevators and trains for economic and braking. As you see the trains in the given figure. This was later used extensively on mountain grades in electrical train operations and for interchange of energy in elevator groups. Additionally, Sprague developed a distorted system of compound field magnetic winding that maintained a fixed non-sparking position of commutator brushes and a three-point wheelbarrow suspension of axial mounted gate motors for electric railways, which was soon used universally for trolley CR equipment. Let's go to the next slide. Electric pioneer. By 1886, Sprague's company had introduced two important inventions. First one, a constant speed non-sparking motor with fixed brushes and regenerative braking. Second one, a method of braking that uses the drive motor to return power to the main supply system. His motor was first to maintain constant speed under varying load. It was immediately popular and was endorsed by Edison as the only practical electric motor available. This regenerative braking system was important in the development of electric train and electric elevator. Let's go to the next slide. Success of Sprague's equipment. Sprague's incorporated many of the inventions in the equipment his company installed for the Richmond Union Passenger Railway in 1887 to 1888, the first large-scale electrical trolley line in the world. Within 2 years of its reopening, 110 electrical railways using Sprague's equipment were built or under contract, including systems in Italy and Germany. In 1890, Edison General Electric Company, which manufactured much of Sprague's equipment, purchased and absorbed the Sprague's Electrical Railway and Motor Company, and Sprague turned his attention to the field of vertical transportation, which changed his life. Electric steel. Julian Sprague invented a system on street cars for collecting electricity from overhead wires. His spring-loaded trolley pole, invented in 1880, used a wheel to travel along the wire. Using his trolley system, Sprague installed the first successful large electric street railway system, the Richmond Union Passenger Railway, in Richmond, Virginia. This was the first large-scale and successful use of electricity to run a city's entire system of streetcars. To get electricity to the streetcars from the powerhouse where it was generated. An overhead wire was installed over city streets. A streetcar would touch this electric wire with a long pole on its roof. Back at the powerhouse, big steam engines would turn huge generators to produce electricity needed to operate the streetcars. A new name was soon developed for streetcars powered by electricity, and they were called trolley cars. Let's go to the next slide. Electric elevators. While electrifying the streetcars of Richmond, the increased passenger capacity in the street gave Sprague the notion that similar results could be achieved in vertical transportation. The hence are called electric elevators too. We saw that increasing the capacity of elevator shafts would not only save passengers time but would also increase the earnings of tall buildings. With height limited by the total floor space taken up in the shaftways by slow hydraulic powered elevators. Sprague Electric Company. In 1892, Sprague founded the Electric Elevator Company. While working with Charles R. Pratt, he developed the Sprague-Pratt electric elevator. The first was installed in the Postal Telegraph Building in 1894. The company developed floor control and automatic elevators, acceleration control of car safeties, and a number of freight elevators. At the net or and 584 elevators are installed in worldwide. At last, Sprague sold his company to the Otis Elevator Company in 1895. As you can see here, it was the Sprague Electric Company figure. Let's go to the next slide. The constant DC motor. First of all, what is constant DC motor? The constant DC motor refers to the standard electric motor which has normal operating speed that is theoretically or practically constant. As example is synchronous motors, low slip induction motors, or conventional parallel winding DC motors. In this case, you can call an induction motor, which is defined as a constant speed motor. The rotor flux rate lags slightly behind the stator flux, and there is a relative velocity between the stator and the rotor. The difference in engine speed changes slightly with increasing engine load. In a vacuum, this is called sliding speed. There is very little slip at idle, and the torque generated by the engine matches idle and friction losses. Consequently, at ideal speed, the motor rotates at almost synchronous speed, and it is equal to 120 F by P. Let's go to the next slide. Note: when the load increases, the motor tries to transfer the load to the mechanical load, and in this process the motor speed decreases. Decreasing the motor speed causes slip to increase, and the motor draws a large current from the rotor to transmit torque, which tends to return the motor speed its original speed. The slip of the induction motor ranges from 3% to 5% of the synchronous speed. As the inductive load increases, the slip decreases within the specified range. Therefore, an induction motor can be called as constant speed motor. Now let's go to the next slide. Understanding the constant motor. One of the most often overlooked parameters of direct current motors, both brush and brushless, is the Km or motor constant. The motor's constant expressed as Km defines the ability of a motor to transform electric power into mechanical power. One of the most often overlooked parameters of direct current motors is the Km or motor constant. The motor constant defines the ability of a motor to transform electric power into mechanical power. The motor constant is calculated by following equation, and it is also represented in English units. Km is equals to Kt by root Rt, where Kt is the turquoise sensitivity in amperes and Rt is the terminal resistance in ohms, expressed in ohms. Units of Km are Oz, In by root watts. Let's go to the next slide. Here you can see the constant speed DC motor diagram. The outer round circle is steel yoke and the S and N poles are called pole pegs, and there is a wire like thing is called field winding, and there was a holder to the carbon brushes is called armature laminated, and the plus minus signs outside the motor are called fuel supply. Fuel supply is in the motor, and there are carbon brushes and the commutator inside the circle, and their brushes, and these are all included in this constant speed DC motor. And here where the electricity produces by converting mechanical that converts direct current electrical energy into mechanical energy. And here is the look of DC motor in practical or very defined manner. Let's go to the next slide. And here is the legacy of our well-known Frank Sprague. Sprague developments in electric traction. Let cities grow larger while his development of the elevator permitted greater concentration in the commercial sections and increased the profitability of commercial buildings. Sprague's invention made modern light rail rapid transit systems possible, which today still function on the same principle. Yes, Sprague developed many or is impression made today alive in today's larger cities and today's electrical elevators and everything, and today's modern light rail, which was the greatest invention or greatest favor or greatest legacy in the electric field engineering. Let's go to the next slide. And his death. Frank Sprague died on July 25th, 1934, by contributing the development of constant speed DC electric motor and excited to the human life, and his contribution lives long until the human dies. So, his contribution to the development of constant speed DC electric motor made the human life to grow another step. And here is our PPT about Frank Sprague's events and about the constant speed DC motor. And thank you everyone. Thank you.